what OSI model was? OSI model was only used to understand the computer networks, not the implemented version. Today we will be discussing the implemented version, actually implemented on the hardware, which is TCP/IP protocol suite. So these are two different models, but generally we categorize one is a protocol suite and one is a model. So we have already understood what is OSI model, how it is using the communication from one place to another place, but that is not actually implemented on the hardware. There is only theory. We just need to understand. So both purposes were there only. One to understand the communication, and one is used by the vendors who making the chips, because they have to know what is the process of the network from computer to cable, cable to switch, switch to router, router to internet, and all that. They have to understand because they need to make the chips. But that is not implemented on the computer hardware because that model is very complex. So they have made a very simple concept from the OSI model as per the protocols, which is TCP/IP. So what is mean by TCP and IP? TCP is basically one of the protocol in thousands of protocols, which is very important, and IP also very important. That is why they have started this model name is TCP/IP. There are hundreds of protocols we need to understand, but these two are very important. Like if we don't know TCP and IP, we cannot communicate over the internet. For example, TCP is a transmission control protocol. Transmission control means the thing which is controlling all over the communication, that is called TCP. Transmission control, that protocol is controlling the transmission. For example, if you are having too much traffic on the roads, if there is no one to control that traffic, then there will be no use of that roads and infrastructure and everything, because there is no control. There are no cameras, there are no lights, there is no person to control the traffic. Then if there is no control, then there is no use of it. That is why that protocol is very important inside the organization and inside the working of overnet or overall or internet. And the second one is IP. IP is an identity of the computers. Like if you are going outside of the world, or even if you are traveling inside your country, so you need an identity, local identity and global identity. Local identity, you have already the MAC addresses. If you want to communicate inside the LAN, switches will help, and switches will just throughout all the network you can go with the help of MAC address, which is built in on the NIC. But if you want to travel outside the network, then you need another identification. Like same in our people communications, when we have to travel inside the country, we don't need password. But if we want to go outside the world, we need passport. So passport is our IP, and our national ID is our MAC address. So same like in the network, if you want to travel inside the LAN, there is no need of IP address. You can communicate all over the internet, all over the network inside with the help of MAC only, because switches are building the MAC table. Whenever someone trying to go inside to someone other, then switches will build the MAC table, and they will know from where it is coming and from where it will go. But if you want to go outside, your packet or frame will go to router, and router will not understand the MAC address. They only understand the IP addresses. So that they will be using the IP addresses, they will put the IP addresses on the frame. It will become packet, and packets will be traveling out the world. There will be no use of MAC address all over the internet. So these protocols are very important. One is controlling the communication, and one is your identity. Without control and without your identity, you cannot travel. For example, same traffic example, if we will take, there is no traffic warden, there is no camera, there is no lights, then there is no control. Similarly, if you don't have a plate number, you cannot run your car, you cannot run your vehicle. So you can understand that TCP is the control of the traffic, and the IP is a identity of your car. So both are required. So that is why they have given the model name TCP/IP, because we need to understand all the protocols inside this model, but these two of them are very much important. That is why they have given the name TCP/IP, because these two are the major ones. If we don't understand these one, we cannot understand anything, because all the other protocols just support these protocols. It is a protocol suite, is a set of communication protocols. Like it is a protocol suite. Protocol suite mean If you have your passport with you, and if you are going outside, you have all the control to go outside, both are fine. But you need the supporting things also, like you need bag, you need other things like your clothes and shampoo and other things you need to go, that are necessary, but not 100% sure that you need it. If you need it, then that is why they have given the name is suit mean the other protocols will be there, you need to understand by supporting this one for to successful communication. It is the foundation of the internet and provides a comprehensive frame of the networking. If we basically the IP, which is giving us all the functionality all over the internet. If we don't know the IP, then there is no possibility of IP, because all the routers are sending communication between each other all over the world with the help of IP. So that is why it is the foundation of the internet. Without IP, there is no foundation, there is no internet. Okay, now we have to start multiple hundreds of protocols, rules and regulations, but we cannot understand all over the 1, 2, 3, 4, 5, 6. So that is why we have divided all the protocols into 4 layers. Similarly, when we want to try to understand the communication, we have started from OSI model, and OSI model was very complex. So that is why we have divided into 7 layers. Now we are trying to understand the communication protocols, but communication protocols are hundreds of protocols. So that is why we need to divide them in the layers. So we have divided here the protocols in 4 layers. Some of the people divided this model into 5 layers. That is why you can see on the right side. Usually, generally, people divide it into 4 layers. But some of the books you will see over the internet, or some of the videos, or some of the articles, you will find the 5 layer. Basically, some people are dividing this layer into 2 parts, same as OSI model, physical layer and data link layer. But the problem is, if you will give the name physical and data link, that will be similar to OSI model. So we will not understand we are talking about OSI model or we are talking about TCP/IP. So that is why people are not using the 5 layer naming convention. They are using 4 layer, because the layer name is here different. So you can also say their link layer, and you can also say network support layer. So there are 2 names associated with that layer: network support layer. So you can say the first layer of the TCP/IP model is a link layer, or simply you can say that the network support layer. Usually you will see in the books network support layer, or sometime you will see link layer. So, but most probably people are using nowadays network support layer, because this layer is supporting to the network, means physically and data link layer. Like until the switches, before going to the network, there are 2 processes. One is physical process, which is happening inside the computer and cable, and the second process is happening inside the switches, which they are communicating each other before going to router. So there are 2 processes which we have to use before go to the network, before go to the outside of the world. So that is why we are calling it network support, not network layer, network support. This layer is supporting network, like physically and logically inside the switches. So that is why we are dividing it into. So this layer manages the physical addressing data frame transmission over the physical medium. It deals with the hardware and network interfaces. So basically 3 major points here. Physical addressing mean MAC addressing, which is already have on your MAC NIC, and that is used by the switches to send communication between each other. So that is called physical addressing. So one major purpose of this layer is, we have already understood on the OSI model, that the second layer of the OSI model, data link layer, handles the physical addressing. The second is transmission over physical medium. That is the function of layer 1. Physically connected cables with your NIC, or physically you are connecting with the Wi-Fi to your computer as a Wi-Fi access point. And it deals with the hardware. Why it deals with the hardware? Because your computer is also hardware, your cable is a hardware, your switch is a hardware. So these all things as a hardware communication each other. So that is why this is also functionality of layer 1 of OSI model. And also the cable is connected to the interface. Interface mean network interface card. whichever interface you are using, physical interface and logical interface. If it will be physical, you will be connecting cable, or if it is logical, you will be connecting to Wi-Fi. So these four functions of the TCP/IP model, but here we are not going to understand the functions. We already know the functions in OSI model. We have to discuss here the protocols and technologies in TCP/IP mainly. So the first technology here to understand is Ethernet technology. What is mean by Ethernet technology? Ethernet technology is, we already understood in OSI model also, that which is connecting our internal network to the switches. So if we are not having switches, we can connect hubs and we can connect bridge. But bridges and hubs are absolute because they were just sending the broadcast to all the network. That is why nowadays Ethernet technology using only the switches. But in Ethernet technology, we have standard 802.3 standard, which is compared by the IEEE organizations, that you have to use the same standard. In this standard, we need to use the topology. Like in Ethernet technology, we can use star topology or we can use the bus topology. But bus topology is older than, because this were using only one cable, single cable. But nowadays we are using central device as a switch, so we are using star topology. The other technology is Wi-Fi technology. In compared to the physical technology, we are using now cable-less technology, like with the Wi-Fi. And the third one is PPP. PPP means we also need to connect our routers between each other, that we are dealing with the technology to technology. For example, we are connecting one router to another router, or one multi-layer switch to another multi-layer switch, to make it point-to-point connection. Like we are sending our traffic from Zabil Sharjah to Zubail Dubai, but both are our own network. So we need to handle this in between communication between the two organizations. So that is why we need to use PPP, point to point protocols. So these three technologies basically are the link layer technology, where we use the Ethernet technology, Wi-Fi technology, and PPP technology. Why? Because these are providing the support to the network. If we are not using internal Wi-Fi or Ethernet or PPP, we cannot go to the internet. So these three technologies are supporting us to go to the internet. So after using these technology, if we move forward to the network, we already know that third layer of the OSI model is a network layer. But here we are giving little different name, as I already said that we don't need to match the names. So that the function is same, but the name is little different. In OSI model layer 3 network layer, here we are calling it internet layer. Network or internet, is the same, but network is internet is the biggest network. Like it is also a network, but internet is very big network, like networks of network. So we are calling here inside the TCP/IP this one internet layer. It handles the logical addressing. Same we understood in OSI model, that if your data as a frame going from switch to router putting the IP addresses on that will become packet. So that is called logical addressing, because IPs are not manufactured on any device. We are providing the IP addresses. So that is why logical addressing is not a physical part, which is just we are giving a number to the identity to the routers or identity to the computer. That is called logical addressing. The second function of this is routing. We already understood in OSI model that routers send packets across each other, from one router to another router to another router, which is called routing process. So they are basically sending traffic through packets from one place to another place. So the second function of internet layer is the same as OSI model, is routing of the packets. So to send packets from one place to another place. And different networks manage packet forwarding. So sometime we need to send only forward the packets, not only routing from one place to another place to another. We just need to forward the packets, like just to understand the second router is alive or not alive. That is not actual communication. So we just need to forward some packet to understand which one is allowed. For example, ARP packets, ARP, address resolution protocol. We need to convert from MAC to IP, IP to MAC. Sometime because routers are sending traffic by the packets, but inside the packet, there are frames. Inside there are MAC addresses. When the communication will come back to router, it will also send it to back switch. So routers at least need to know the understanding between MAC and IP. They are not using the MAC, but sometimes they have to translate from IP to MAC, MAC to IP. That translation happen with the help of ARP packet forwarding. So always routers are sending ARP packets each other. That is called packet forwarding. So sometimes we need to use the packet forwarding also to make possible. So these are three major functions of the internet layer. They are sending automatically. There is a time. For example, they are taking the MAC address from the frame and they are taking the IP from the packet. So they are comparing each other, which IP is from source and which IP is from destination. Similarly, which IP is from which MAC is from source and which MAC is from destination. Because all four technologies required. Because whenever you will come back, you need to know the MAC address also. If you know the IP address of the host, but you are sending to different MAC address, it will not possible. So the same MAC address which is bound to the same IP address. For example, my laptop have one IP and one MAC. So that should be same. When the communication is coming back to my system, so it should come back to same IP, same MAC address. So sometime router and switches need to translate which MAC address I have. I don't know the IP. I have IP, but I don't know the MAC. For example, switches don't know the IP addresses, router don't know the MAC addresses, but they have to use both to send it to perfect communication source and destination. So what they are doing, they are sending ARP message. For example, router know the IP address, but he want to send back to the switch, but he don't know what is the source MAC address. So he will send one ARP message from router to switch, and he will be asking that give me the give me the MAC address according to this IP, because I know on IP only. For example, similarly, when you are going to the airport and if you want to go back to your country, you are coming to the airport, Indian airport, with the help of passport. But when you have to go inside India, they will be asking your ID, Indian ID, because they will know that you are an Indian person. So though both required also, because when you are coming back you need IP, but when you are going out you need passport. So passport and ID both are required, but one is used outside and one is used internal. But router and switches both required MAC and IP. So whenever router don't know one thing, they can send traffic to the other side and they are asking give me alternative things. IP I have, give me MAC address. Yeah, they will communicate each other with the help of are packets, address resolution packets. Address resolution packets just simply working to know the other part of the communication. If someone knows the IP, they want MAC, they will send ARP message. I have IP, I need MAC address. Some devices don't know the MAC, but they are having IP, so they are sending another ARP packet. They are saying, I know MAC, I don't need IP. So they will be replacing each other unknowingly. So that is basically sometimes we need required routing to go outside the router. Some might need to packet forwarding each other. Okay, three most important protocols here. IP, we already understood that IP is an internet protocol which is having the highest priority. These one we know are packets which are we are packet forwarding to know the other identity, MAC to IP, IP to MAC. And there is another one, third one, ICMP. ICMP mean Internet Control Messaging Protocol. Why we are using this protocol? We are using this protocol as a diagnostic purpose. Diagnostic mean we are using a tool, ping tool, because we need to check before sending the communication from one and another by sending ping packet. Ping packet mean that we are sending 4 packets from one place to another place just to know you are alive or not alive. For example, before you were coming, I send you one message that you are coming or not coming. So the same process will be happening when we need to send traffic, ARP message or packet forwarding or routing, whatever it will be after, but we need to check if the destination is alive or not alive. For example, I am just sending ARP messages to know the MAC address. I have the IP, but the router next switch is not alive. So what will happen? There will be just waste of time. So first we will send ping messages, 4 messages that will be going to, there will be no data inside. There will be just simple ICMP messages, Internet Control Messaging Protocol. So there will be no data, only the communication will be that to check the network device is available or not available, or the path is clear or not clear. Yeah, just bit testing purposes. So ping tool use this protocol ICMP to just check the connectivity. So that is the purpose of ICMP, to just understand the communication is alive or not. After checking the communication, it will go ARP messages, or after getting the ARP messages, it will go to. So basically, this one is for testing ICMP. ARP message will be changing the MAC to IP, IP to MAC. And the third one is for internet communication. So these are basically three major purposes of the internet layer. One is using just for testing purposes. First, we will test by sending some ping packets. If it is alive, then we will send ARP message, because we know only MAC address, we need IP. If we know IP, then we need MAC address. So that will be translating between MAC to IP. And then third one, which will be the actual forwarding of the packet, or which will be actually routing of the packet with the help of IP addresses. So these three major protocols used for these three purposes. Same like here on the first layer, there were four purposes of the functions, but we need three technologies. Here we have three functions which we required three protocols, major protocols behind, because the TCP/IP model is to understand the technology behind, or protocols behind working the functions. Okay, after that, when it will go to the network, it will be making the reliability of the transfer. For example, if we want to send reliably data here, and after that we need to confirm the data is reached or not reached, so we need to make sure the data is reached. So there are two protocols we use for the reliability: TCP and UDP. TCP is a transmission control protocol, which we understand that is controlling the network traffic, how it is handling and how it's making sure that data is transferred 100% by sending three-way handshake. Three-way handshake means first sender will send a request as a sync message. I am syncing with you. The destination will sync again back, and it will send acknowledgement that I am available. Then you can send data. And third, there will be another acknowledgement from the source to destination that okay, I acknowledge that I have sent completely data. So there is a three-way handshake. First handshake will be sync, and the second one will be sync acknowledge, and the third one will be acknowledge. So that is the three-way handshake, if you just want to understand three-way handshake. So three-way handshake will happen with this TCP/IP, and it will make sure that the communication is 100% successful. But sometime it will become very lengthy, that any time just sending packet, something happened to one packet, we are sending thousands of packets. So anytime 2-3 packets just lost and then need to send again. So that will be duplicating data, and that will be wasting time. So sometime we need to just send voice or video, so that we don't need TCP handshake. Because if I am talking to you and in between my communication some words are missing, and later on sometime 1 minute or 2 minutes the same characters will be coming back to my conversation, it will disrupt my communication. So sometimes we don't need retransmission, sometimes we don't need three-way handshake, and that time we use the UDP. What UDP is doing, UDP is just sending user datagram protocols just by one direction. There is no acknowledgement, there is no three-way handshake, it's just a two-way process. Just you are sending, the other one is sending the acknowledgement. Okay, I got the data. So there is no need of three-way handshake, and there is no need of retransmission. This protocol we usually use to send voice and video, because in voice and video we don't need any retransmission, we don't need any three-way handshake. My voice is approaching to you or not approaching to you doesn't matter, because if I am talking to you, if there will be some disturbance, there is no problem, because some words will be just going up and high, and there is no, if I will sending back to you that words, and that will be miscommunication. So that is why we need both TCP and UDP. One is reliable, TCP is reliable, UDP is not reliable. In case of not reliable, why? Because it is not making sure in three-way handshake. But that one we also need sometime with the help of audio and video transmissions. So we need both. Sometimes we need reliable transmission, sometimes we need unreliable transmission. Usually we use TCP for the data transmissions, downloading, uploading, or these kind of mails and all that. But when we are using audio video transmission, then we are using the UDP. It is also handling the data flow. Data flow means if I am sending you data with the very fast speed and you cannot catch it, that will be no communication, or that will be burden to you. So we need to communicate each other the data flow, which data flow I need to send and which data flow you can receive. For example, I am connecting two computers each other. One computer is having 100 Mbps speed NIC, and one computer is having 1 Gbps speed of NIC. So what will happen? The one computer which is having 1 Gbps speed, which will be sending traffic to 100 thousands of packets, and that cannot receive. So communication will be only possible until 100 Mbps. So data flow we need to. And the last function of this layer is error detection and retransmission. Error detection means why? Because if TCP we are using, something happened to some packet, that should be retransmission. Because if something is lost between the TCP communication, that should be replaced and another packet. For example, I have sent you one email. Yeah, it will be automatically replaced because on the frame structure there is one starter and one end. In the end trailer we are putting the algorithms which are calculating the errors. If something happened to one frame, that should be retransmit again. So for example, host is sending 100 packets and sender is receiving 100 packets, but after finishing the transmission, destination receive only 98 packets, so two are remaining. So the source should again send these two, which one was having errors inside, or they are not reached by somehow. That is why they have to retransmit again. So there are three functions: reliability of the data flow, and the third one is error control. With TCP we are handling all three. Inside TCP messages, data reliability also we are checking. Also we are checking the data flow and error recovery. But in UDP we are not checking anything. We are just not checking reliability. We are not just checking data flow, but last error detection will be there. Error detection will be there in UDP, because if UDP packet loss, then what will happen? So sometime we are using, but sometime we don't need. For example, if I don't need to correct the message in the voice communication, that there is no use of the. But sometime some critical UDP packets we are using, but mostly we are not using these three things. We are not checking the reliability, we are not checking the data flow, and we are not checking the error. But sometime data flow and error detection we need to check in the UDP also, because if UDP is sending more voice and the other cannot receive more voice, then we have to check the data flow in UDP. So usually 50-50 we use data flow, 50-50 we use error detection. But mostly we use only data flow for UDP, no reliability, no error detection. So these are two most important protocols, but obviously for data flow control, there are multiple other protocols we are using. For error detection and mechanism, there are 6-7 different protocols, which is not a concern here, because if we will be going deep inside how data flow is happening, how error detection is happening, we need another separate 1 hour to understand these protocols. So in this CCNA, we don't need to go that deep to understand which protocols we are using. For error detection, there is a parity check bit, there is multiple FCS mechanism, and also for data flow, there are multiple protocols we need to understand. But here we just need to understand basic purpose of UDP and TCP. But there are multiple protocols for data flow, and there are multiple packets for error detection. If we just have the concept of these three things, then we can understand that reliability and unreliability checked by UDP TCP, and UDP TCP is also handling the data flow and error control. After handling this communication and at the level of transport, we need to send it to the destination's application layer as same application layer as the OSI model. Similar function, but at OSI model, we understood the functions like end-to-end applications, handles, the high-level protocols, data formatting, application-specific functions, which were three layers like upper layers of the OSI model, which were performing translations, encryptions, and also sending to the other side of the application. All these kind of things we understood. But here we don't need to understand the functions. We need to understand the protocols. So first protocol we will be understanding here, HTTP. HTTP is a hypertext transfer protocol which is used for the web. When we are sending traffic from one website to another website, or we are opening Google or something web browser, so we are using HTTP. But here we need to understand not only HTTP, we need to understand HTTPS. What is mean by HTTPS? S basically is used for SSH, secure shell. Secure shell mean every protocol nowadays using secure shell, that is giving encryption to that, because HTTP was plain text. Whenever we are searching for Google, we are downloading something, that is plain text. Anyone can sniff in the network and anyone can hack our transmission, or anyone can use it illegally. So nowadays all the protocols are using SSH. SSH mean that only we add with the protocol name S mean SSH. SSH means secure shell. We are putting some encryption algorithm and we are using the technologies of SSH, secure shell, to secure our communication with the help of encryption. So we will just add HTTPS. S mean SSH. Similarly, FTP is used for file transfer protocol, for uploading and downloading files. Same FTP is also using S, but FTP is not putting S at the end. STP is putting S in the front. SFTP. So SFTP, same S is used for SSH. So FTP transmission will be also secure. For example, we are downloading or uploading some files, that is not secure. Someone can sniff our file or someone can use our file. So we are also putting SSH and we are not using S at the end. Same like as HTTPS, we are using S at the start. S means same SSH. SFTP. SFTP now. So similarly, SMTP we are using for mail. Whenever we are sending to someone mail, DNS is used for that domain name system. Domain name system mean same like ARP. ARP was doing translation between IP to MAC, but here we need to translate from addresses to IP. For example, we are searching in the web browser google.com. That google.com we know, but routers don't know google.com. Routers knows only IP. So if we want to convert the names to IP or IP to name, then we need DNS. So for example, whenever I am opening web browser and I am typing google.com, that Google should have some IP address. The router can take us to the Google only with the help of IP, but router don't know the IP address. Whenever request will go to router will send traffic to the DNS. DNS will resolve it from Google name to IP. It will give the IP address of the Google, and then it will be cross transmission will go to the Google server for the google.com. But first it will be translated by the DNS, domain name service. Telnet is also a non-secure version when we are configuring the devices remotely. For example, I am working as an administrator in company. I am sitting at home. They are giving me authority to log in from home, remote desktop. So we use Telnet to access the devices from outside or remotely. But this Telnet is not secure. Plain text it will be going. There is another version of the Telnet is SSH. We can use as a direct communication, like that is used SSH. So there are other multiple protocols we need to understand, but these are the major ones. If we know these, then we can understand the technology, how it is working. For example, at physical layer, if you know these three technologies, and the internet layer, we know these three, how network or internet is handling traffic, and how communication is possible, reliable, unreliable, and what are the basic application layer protocols. But of course there are hundreds of more protocols, other protocols we need to know, but these are general. If we know these, that will be enough to understand the communication. Similarly here, application layer, transport layer, internet layer, and see the name came network access layer. Here we were using the link layer, but some of the, I told you that some people are using network access layer. So there are token ring and Ethernet technology, PPP, frame relay. These are two basically old one which we are not using nowadays. These were very old. Like same, I told you in Ethernet technology, we were using two topologies, bus topology and star topology, and there was another topology, ring topology, like in circle. So this technology was used in the ring topology, which is nowadays we are not using, and frame relay we were using before. Now we are not using frame relay also. So we are only using the Ethernet technology and PPV technology, and the third one is Wi-Fi, which is PP is same Wi-Fi. Yeah, no, PP is a different to communicate between networks. Like yeah, Wi-Fi and Ethernet is same. Ethernet is using physical cable and Wi-Fi is using without cable. After that, if we are going to internet layer, so internet is layer same, IP, ARP, ICMP. These are the famous protocols we need to understand. IP, ARP, ICMP. IGMP basically is just a variant of ICMP, and IPsec is for security. Here we have to know the TCP and UDP, and simply here we knew HTTP, RDP is for remote desktop, DNS, SMTP, Telnet to secure the devices to connect the devices remotely, and the SNMP mean they need to manage the devices. So the goal is to provide physical interface, and the goal is to frames error recovery, and the goal is routing. And here we need to establish the data segments with TCP UDP, and here we need to use the protocols. So these are the different layers. Similarly, if we want to know more about what is mean by HTTP, it means hypertext transfer protocol. FTP means file transfer protocol. SMTP mean simple mail transfer protocol. DNS mean domain name system. I have just written names here because no need to write, and these are using for web browsing. These are using for files transfer between. These are using for sending emails, and these are using the domain name to IP addresses. So these are translating between this to this and this to this. After that, transport layer use two. One is reliable and the other one is non-reliable. One is connection oriented and one is connectionless. Because in TCP we are making connection with three-way handshake properly, and in UDP we are not making. So if someone will ask you which one is connection one and which one is connectionless, so UDP will be connectionless. After that, internet layer, we understood the IP. We already know ICMP is used for ping to communicate, check, and ARP is used for the MAC to IP, IP to MAC. So basically, this one is translating this and to this. Maps the IP to MAC. And link layer, we are using three technologies: Ethernet, Wi-Fi, and PPP. And also here we can say that other technologies were there, token ring and frame relay, but these are not used nowadays. So if we will compare between these two models, so generally we can say OSI have 7 layer, which we already know, and this one have 4 layers. Sometimes people are calling these 5 layers, but if you can see picture here, so that will be 1 layer, that will be 2 layer, and that will be 3, and that will be 4. And these 3 layers are joined together, and these 2 layers are joined together. In between these 2 layers are have the similar functionality. But here we are calling network layer, and here we are calling internet layer. Here we are calling transport layer, transport layer. These names are same. These are little different. We can also say network, but there is a separate name. And there we are using network access layer and data link. But some people are using these two same name to make it 5 layers. But that is why we are not using it. So there are the naming: physical, data link, network, transport, session, presentation, application, and here link layer, internet layer, transport layer, application. So we have to come by this, and we have to come by this, right? TCP IP we have to go from down to up, and OSI we have to come up to down. Why? Because we have to understand the communication from OSI model from physical to logical, and in TCP we need to understand from application side to the outside. Detailed separation of function, but most simulated on the combined functions. We are putting functions here combinedly. That is why TCP are combining things and OSI are explaining things. This one is related to hardware and transmission media, and here we are at framing, just understanding the framing, Ethernet technology and all. This one is called MAC address, and here we are calling network access. Here we are dealing with routing, and we are routing here, IP addressing. Same functionality. This one is reliable and transmission, and this one also using TCP UDP protocol. Here we just check reliability and flow control. Here we use TCP and UDP. And here we are using session management, but here we are using only often within the application layer. So these are the same functionality, transmission, and after that 7 layer is network services and the end user protocols. Similarly, design, this is a conceptual model only. We are not implementing anywhere, just to understand it. And this one is the implementation model, which already implemented on the system, because this system is very simple. After that, mode granular, this one is a practical method because we are using in practice. This one is developed by ISO organization, International Organization of Standardization, and this one is developed by ARPANET, which ARPANET was used first time in US, first time when the internet start. They have made one organization to start the internet. So they have used first internet between the armies. One army can communicate to other army. So they have given this task to one department, which department was called ARPANET, Advanced Research Project Agency Network. So there was one organization which was making for them communication is possible between one army to that army. So from that in 1970s, first time start the ARPANET, and after that they have given this ARPANET to outside the world to check the other organizations and to the other countries. So you can use also these standards. So that becomes internet from ARPANET. Basically, first name of the internet was ARPANET. Yeah. So from ARPANET it becomes internet. Okay, Ji. If you have any questions to understand these protocols, functions of TCP/IP model,